For lesson 5, we have two tables. So what we're going to do is look at the patterns in the table to complete it. Now, as I look at table A, I go from 2.5 to 10 to 17.5 to 25. So overall, this looks like a consistent increase or a linear increase. So here, what I'm going to do is find the common difference, or my slope, as x increases by 1. What does y increase by? So if I go 10 minus 2.5, I get 7.5. And as I go 17.5 minus 10, it's again 7.5. Now, to go from when x is 3 to x is 4, I can take 25 and just add 7.5. And I get 32.5. However, if you look at the table here, x is 25, and we have to figure out what the y value is. So the most efficient method for doing this is to find an equation. So here, remember, our equation would be y equals mx plus b, where m is your slope and b is your y-intercept when x is 0. So if you notice here, what we're counting by is 7.5. So as x increases by 1, y increases by 7.5. That's my slope. So far we have y equals 7.5 times the x number. Plus, if I look for my b number is the initial value when x is 0, which is right here. That tells me b is 2.5. So in this case, to figure out what y is when x is 25, we do the expression 7.5 times our input of 25, and then plus 2.5. So I'm going to go ahead and use a calculator to plug all that in. So 7.5 times 25 plus 2.5, and I get 190. So over here now, if I look at table B, I go from 2.5 to 10, but then if you look, I go from 10 to 40. So this is definitely not a linear increase. And I can see, is there a common multiple? Am I multiplying by a factor to make this bigger? So I notice here, if I go 40 divided by 10, that is going to be multiplying by a factor of 4. Same thing here. I know that 2.5 times 10, or 2.5 times 4 is 10. So to go to the right on the table, as x increases by 1, I can just multiply by 4. So here, I could take 160 and multiply by 4. And I get 640. However, I can't do that here for 25. I could keep multiplying by 4, but that would be a lot. So what I'm going to do is find the equation. So remember, for an exponential equation, we have y equals a times b to the x power, where a is our initial value, and b is our growth factor. So what you would do is just plug in your numbers. So our initial value is 2.5. And our growth factor is 4. So our equation would be 2.5 times 4 to the x power. So for this problem, I'm going to put the expression 2.5 times 4 to the 25th power. And if you notice, that is a very, very, very large number. In fact, it's so large that you can't really put it in a calculator. So I'm going to put 2.81 times, this e means times 10 to the 15th. So it's so large, we have to use scientific notation.